Hello, my name is Britton, and today we will be going over the trig function and right triangle trig ratios. So first, we will review SOHCAHTOA. So SOHCAHTOA will be your tool when solving for these trig ratios and functions. SOHCAHTOA is broken into three parts: SO, CA, and TOA. SO stands for sine equals opposite over hypotenuse. CA stands for cosine equals adjacent over hypotenuse, and TOA stands for tangent equals opposite over adjacent. Terms. So sine represents the y value of an ordered pair. Cosine represents the x value of an ordered pair. Theta is this sign right here, and it represents a placeholder for an angle that we have not yet found. So, for example, when finding a trig ratio, instead of saying, this area here, we say sine of theta. So instead of saying sine of this corner, sine of theta. Trig function is a function that relates to an angle ratio, example, cosine, sine, tangent, and much more. Trig ratio is the special measurement of a triangle in which we use to find the function. So here is an example of theta right here in the right triangle. So when we are solving for these, you can see that x over y is like our normal ordered pair. However, in this ordered pair, x stands for cosine and y is sine. And then your radius always stays 1. X is also, in this case, adjacent from the theta. So x is adjacent from the theta. And the y is also opposite from the theta. And then 1 is again just staying as your radius on the hypotenuse. So now we're going to find the following trig ratios. Well, first we're going to find x over 1 on this side. So x over 1, again, your ordered pair, x is the cosine, 1 is your radius. X over 1, we would be adjacent over 1. So we're going to put over here, or it's also the same thing as x, because anything over 1 is that value. So we can just say x or your cosine theta. Now we are going to look at y over 1. Y over 1 is again the same as y, and it's opposite over 1. So y or sine. Now that's also based on your ordered pair. Now when we move on to x over y, we're talking about adjacent over opposite. And adjacent over opposite, if you remember SOHCAHTOA, is not going to be anything, because it's going to be the inverse of tangent instead, because tangent is opposite over adjacent and this is adjacent over opposite. So we're going to have, again, inverse of tan. So it's not one of our answers over here that we've already solved for this angle right here. Or this triangle right here, sorry. Now we're going to move on to y over x. So y over x would be opposite over adjacent. And if you remember, if you refer back to our SOHCAHTOA, opposite over adjacent is your tangent. So we did find another value over here. Now we're going to move on to this triangle up here. So a over b. So we're going to solve for a over b. Again, this is going to be your adjacent, and this is going to be your opposite, and this is also your hypotenuse. So a over b would be adjacent over opposite, which is again the inverse of tangent. Now b over a. So opposite over adjacent of, again, we're relating back to theta, would be tangent. So now we're going to move on to hypotenuse over the adjacent. So hypotenuse over the adjacent is now going to be 1 over cosine, so that's the inverse of cosine. Now we're moving over to a over c, which is, again, adjacent over hypotenuse, and that is going to be your cosine. Now last but not least, we're going to go on to b over c, which is your opposite of theta over hypotenuse, which would be your sine. And that will be it for finding trig and trig ratios and trig functions. Thank you for listening.